In the previous video segment, I simulated 10 iterations of the game and I obtained 10 different final payoffs. The data about those games are stored but hidden in Excel. We don't see the actual results. We can actually explore the results by right-clicking on this cell and saying explore browse results, and it will show us again the distribution. That is the distribution of possible values for this cell with probabilities for each according to our 10 iterations, right? And then we also know here we have statistics based on the 10 iterations. Minimum payoff that we obtained was -$5, maximum +5, and the mean 0.2. So it might seem that this is an interesting game for us. On average, in those 10 iterations, we won 20 cents. But this is a mean payoff calculated based on just 10 iterations. In statistics, we say out of all possible games, which is the population of games, we just randomly generated 10 possible games. So we selected a sample of 10 games from a population of an enormous size, right? And then in statistics, the question is how confident we are about this value of mean payoff. There is in statistics a term called confidence interval, and I'm going to actually insert a few rows here just to have a little bit more space. So remember, the simulation is still there, and now what I'm going to do is I'm going to also try to determine the confidence interval for the mean payoff. The confidence interval says, let me find an interval in which I will be reasonably certain that the actual mean payoff is in that interval. So first, I will say the confidence level, right? What is the confidence level that I'm interested in? And we can, for example, specify 99% point confidence level, right? 99% confidence level. And then we can enter a mean lower limit, and we will be interested in mean upper limit, upper and lower limit of this confidence interval. This can be done using functions. There is a function simulation result, and the function is called risk CI mean. It's the first function here. This stands for risk confidence interval for the mean. If you click on it, there's more than one thing to enter. So the first thing is data source, which is the final payoff that we are interested, right? We want the mean for the final payoff. Now we have to specify with what in confidence level we want it. And this parameter, you should say it to true if you want the lower limit or lower bound of the confidence interval, and false if you want the upper bound. So here we want the lower bound. We will put true here and then click OK. And I will actually take this formula, copy it, and put it down here and change this to false, right? Because I want the upper limit. And now I will actually change this also formatting to $. And what I want you to see is what we're receiving here is actually very inconclusive. Why? Because if we want a 99% confidence interval, so interval in which we're 99% sure the actual mean payoff is in this interval, and it might be, with 1% chance, it might be outside of it, but that's a small probability, then you see, based on 10 iterations, there is a very wide interval. So that means the actual mean winning could be as low as $2.74 of loss. The mean payoff could be -2.74, all the way up to plus 3.14. So we actually don't know if it's a winning game because this interval includes both negative and positive values, right? So it includes values. Negative would indicate that on average we're losing in the game. Positive values would indicate on average we're winning the game. And if we look at this confidence interval, we don't know if this game will be a winning game or a losing game. Why is this a problem, right? Of course, we cannot answer this game. Is this a winning game? Based on this simulation, we cannot yet answer this. What do we need to do? Well, the answer in statistics says if you want to narrow the confidence interval, you need to have a bigger sample. And the bigger sample in simulation will mean more iterations. So in the next episode, I want to show you what happens when you generate more iterations.